This video we will solve a question on how to derive demand curve for labor and capital when our aim is to minimize the cost with desired level of output. The question is like this: given the production and cost functions is Q is equal to 500 L to the power 1 upon 4 K to the power 3 upon 4. Q is the output, L is the units of labor, and K denotes the units of capital. And we are being given the cost function as C is equal to W times L plus R times K. W denotes the wage rate of labor and L denotes the units of labor, plus R denotes the rental rate of capital, and K denotes the units of capital. We have to derive the demand curve for labor and capital. Okay, so this question was actually asked by a brother. He was confused how to derive them, so let me give the whole explanation here. Okay, so we are being told our aim is to minimize the cost. Okay, that means this is the cost minimization problem. Okay, so how do we write it? We write it simply minimize our cost, which is WL plus RK. Okay, this is our objective function, and our subject to the production constraint. Okay, so such that our Q is equal to 500 L to the power 1 upon 4 K to the power 3 upon 4. Okay, so this is the cost minimization problem. How do we solve these type of questions? Simply we use the Lagrange multiplier method here. Okay, so by Lagrange's multiplier method, what we mean, in this case, this is called the objective function, and this is our constraint. First step in solving this is to set this constraint equal to 0 and multiply it by lambda. Okay, so if we set this equal to 0, it will become Q minus 500 L to the power 1 upon 4 K to the power 3 upon 4 is equal to 0. Okay, and to this we multiply lambda. Okay, let me multiply it lambda. After that we have to form the Lagrange's function. Okay, so let's denote Lagrange's function by L. Okay, so L is equal to, our Lagrange's function is simply our objective function, that is WL plus RK. Okay, and to this we add this resulting constraint, that means plus lambda times we have this Q minus 500 L to the power 1 upon 4 K to the power 3 upon 4. Okay, this is our Lagrange's function. Now to find the the demand curve for labor and capital, what we need to do, we just need to partially differentiate this Lagrange's function with respect to labor, capital, and lambda, and they set them equal to 0 simultaneously. Okay, simply let's take the L subscript L, that means taking partial derivative of this function with respect to labor. Okay, so the derivative of L is 1, so we are left with only W. No L is involved, its derivative is 0. Then we have this the derivative of this Q will be 0 because we are partially differentiating with respect to L. Here the derivative of this will become lambda times this, so the derivative of L here will be, so this will become minus, because plus minus is minus lambda. We have 500, so first the derivative of L to the power 1 upon 4 will be equal to 1 upon 4. Then we have 500 L to the power 1 upon 4 minus 1 is 3 upon 4. Okay, minus 3 upon 4 K to the power 3 upon 4. If you are getting confused, I have done nothing. So the derivative of L to the power 1 upon 4 is simply this 1 upon 4 will become coefficient. Then we have L 1 upon 4 minus 1. By power function rule, if we have x to the power n, its derivative is simply n times x to the power n minus 1. Okay, so we have 1 upon 4 L 1 upon 4 minus 1 is 1 minus 4, which comes out to be minus 3 upon 4. Okay, that thing I have applied here, and we set it equal to 0. Now take derivative with respect to capital. Same process, no L, K is involved, so derivative is 0. That derivative of K is 1, so we are left with or. Okay, then we have minus, okay, minus lambda. Now we have with respect to K, so this 3 upon 4 will become coefficient, so we have 3 upon 4 into 500 L to the power 1 upon 4 K to the power 3 upon 4 minus 1 is 3 upon 4 minus 1 will come out to be minus 1 upon 4. So this is minus 1 upon 4, and set it equal to 0. Then take derivative with respect to lambda. So derivative of lambda is 1, so we are left with this very stuff. No lambda is involved in the first two terms, so their derivative will be 0. So we are left with Q minus 500 L to the power 1 upon 4 K to the power 3 upon 4, and set it equal to 0. Okay, no problem up to this. Now to get the demand function for labor and capital, first we need to solve these three equations for L and K here. Okay, so how can we do? Let us say this is equation first. color istemal. Okay, so this is equation first, this is equation second, this is equation third. Okay, so what will we do here? So if I divide equation first by equation second, so what will happen? So if I write equation first upon equation second, which will give us, so if I transpose it here to save the space, I can transpose this term to RHS, it will become positive. Okay, so let me write it here. Okay, to save the space, because I don't have the space here, I'm using the manual kind of thing here. So this will become W upon R. Okay, is equal to, we have here lambda 1 upon 4. So what is 500 upon 1 upon 4? So let me calculate. We have 500 4 ones are 4. Okay, 5 and 4, 5 8s are 40, 5 zeros are 0. So I got here 1 upon 4. So I will not calculate this. Okay, I will write it as it is. So I have 1 upon 4 500 L to the power minus 3 upon 4 K to the power 3 upon 4. To this we have to divide this lambda, that is we have lambda 3 upon 4 500 L to the power 1 upon 4 K to the power minus 1 upon 4. Okay, so I have divided equation 1 with equation second. So here we can do one thing. So lambda lambda cancel, 500 gets cancelled. Okay, so we are left with 1 upon 4 divided by 3 upon 4. We have 1 upon 4 divided by 3 upon 4. This will become 1 upon 4 into, if I transpose this denominator to numerator, it will get reciprocated and multiplied 4 upon 3. This will get cancelled. We are left with 1 upon 3. Okay, so we have 1 upon 3. Okay, now another thing here we have, I can transpose this L to the power minus 3 upon 4 to denominator. Okay, I have L to the power minus 3 upon 4. I have this L to the power 1 upon 4. I can do one thing. I can write it like this: L to the power 1 upon 4. If I transpose this numerator to denominator, it will get multiplied, but the exponent sign will get changed. So it will become 3 upon 4. So we have, bases are same, we can add up the exponents. This is 1 upon 4 plus 3 upon 4. Okay, so when bases are same, we can add up the exponents. Okay, so this becomes, since denominator is same, we can add up the numerator. Na loga yati yati you are guys 1 divided by L to the power denominator is same. When denominator is same, we can add up the numerator. So 1 plus 3 is 4 upon 4. This gets cancelled. We got 1 upon L. Okay, is among the goes only for this very stuff. So we are left with 1 upon L. Okay, then we have I can use that very logic again, rather that very formula here. I have k to the power 3 upon 4 divided by k to the power minus 1 upon 4. Okay, in this case I will transpose this negative term to numerator, so this will become k to the power 3 upon 4 into k to the power 1 upon 4. Okay, so exponent sign gets changed if we transpose the numerator to denominator and vice versa. Bases are same, we can add up the exponents. 3 upon 4 plus 1 upon 4. Denominator is same, we can add up the exponents. 3 is 4 upon 4, 10 10 are 10, we are left with only k. Okay, obviously, so we have k here into k should be equal to w upon r. Okay, wage rate into rental rate of capital. So basically what we got here, k upon 3l is equal to w upon r. Okay, let us solve it for k, which implies k is equal to transposing this 3l here, so this becomes 3w upon r into l. Okay, this is the value of k here. Okay, now we will just plug this k is equal to this stuff in either this third equation or in this equation. Okay, so let's put this in this equation, constraint function equation. So our q will be equal to, we have 500 l to the power 1 upon 4, then I have k, in place of k I have this stuff, 3w upon r into l raised power 3 upon 4. Okay, so let us solve it. I will solve it here. Okay, then I will rub it to make sense, which means so q is equal to 500 l to the power 1 upon 4. If I expand this, this will become 3w upon r raised power 3 upon 4. Okay, so into l to the power 3 upon 4. Okay, here bases are same, again we can add up the exponents. So we have l to the power 1 upon 4 into l to the power 3 upon 4. They are all being multiplied, so we can add up the exponent. So l to the power 1 upon 4 into l to the power 3 upon 4. So l is same, we can 1 upon 4 plus 3 upon 4. Treta ke zor banya sorry l. Okay, so this is l here. Okay, because this is 4 upon 4, this is l, or let me write it here. So q is equal to 500. Okay, then I have 3w upon r raised power 3 upon 4 into l. Okay, or I can write it like this, l is equal to transposing this term here, so we have q, it will get divided, we have 500. Okay, then we have this 3w upon r raised power 3 upon 4. Okay, so this is our demand for labor. Okay, so labor is a function of the wage rate into rental rate of capital. Similarly, we can find the demand function for capital. That I need to calculate, because the brother has specifically told me that I didn't understand how did you calculate the demand for capital. Okay, how do you arrive at the result? So I will try to solve that very stuff here. Okay, so for that what will I write here? So which implies implies L is equal to Q upon 500 3W upon R raised power 3 upon 4. Okay, I have written this result here. This is demand function for labor, and I will rub this out. Okay, you know how did I calculate it. Okay, yeah, quackro when you use it. So this is demand function for labor. Now to calculate demand function for capital, we just plug this value again into our production constraint function. Okay, so to plug this value here, so we have q is equal to, we have 500. I'm sorry, I have no control on the background external noise. Okay, you have to bear with this. So in place of L I have this very stuff, so I can write Q upon 500 into 3W upon R raised power 3 upon 4. This whole stuff is in place of L. Okay, so raised power 1 upon 4. Then we have K to the power 3 upon 4. Okay, uh, we can write it like this. Okay, we have Q is equal to, I have 500 here. Okay, let's expand this again. So this 1 upon 4 will be for each of these terms. So we have Q to the power 1 upon 4 here. Then we have 500 raised power 1 upon 4. Okay, then we have 3W upon R and 3 upon 4 into 1 upon 4. Okay, into K to the power 3 upon 4. Okay, so this will become here 3 ones are 3, 4 fours are 16. So I will write here 1 upon 16 to save the space again. Okay, now let us remove this bracket also here. Okay, these are all multiplied to each of these. I can transpose this L to 500 raised power 1 upon 4 to the numerator. So it will become like this: 500 into 500 raised power minus 1 is minus 1 upon 4. I have told you, when I transpose numerator to denominator, the exponent sign gets changed. So we have same 500. So we can add up the exponent. So we have 1 minus 1 upon 4 because the exponent is here 1. So 1 minus 1 upon 4 is 500 x वालों 3 upon 4. Okay, so this is 500 3 upon 4. Okay, so I can write here Q is equal to 500 raised power 3 upon 4. Then I have Q to the power 1 upon 4 divided by 3W upon R raised power 1 upon 16 into K to the power 3 upon 4. Okay, now since we have to solve for K, I can write it like this. So we have here K to the power 3 upon 4. K to the power 3 upon 4 is equal to, okay, transposing this, it will get divided. So we have Q here divided by this whole stuff. We have 500 raised power 3 upon 4 Q to the power 1 upon 4 divided by 3W upon R. Okay, 3W upon R raised power 1 upon 16. Okay, I hope this is getting captured into the video here. Okay, so here we can do one thing. If I transpose again this, so we have like this Q which will be equal to, let me write it here. So this is Q upon 1. Okay, so transposing this term here, so we have 3W upon R raised power 1 upon 16 divided by 500 raised power 3 upon 4 into Q to the power 1 upon 4. Okay, simple step I have used here. That means if we have 2 upon 3 upon 4, we can write it like this: 2 upon 1 into reciprocating the denominator, so 4 upon 3. I have used that very stuff. So I hope you know it very well. Okay, let me rub this out because I don't have the space left here to solve it. So K to the power 3 upon 4 is equal to this stuff. Okay, so again, So k to the power 3 upon 4, I got it here. So if I transpose this k to the power 3 upon 4, or let me write it here like this, we have theta uh, 3w upon r raised power 1 upon 16, okay, divided by, I have 500 3 upon 4 theta, sorry, q 1 upon 4, okay. So since the month of first is uh, like, going here, so at times I can tell anything which is out of the context, okay, so bear with me, I'm really sorry for that. So we have k to the power, okay, here you can see we have these two terms, I can just transpose this, okay, this will become q into q to the power minus 1 upon 4, okay. So when I transpose new denominator to numerator, the exponent sign changes. So we have like this, bases are same, this will become 1 minus 1 upon 4, this is q to the power 3 upon 4, okay. So let me wrap this out here now. So I got here q to the power 3 upon 4, okay. Then we have 3w upon r raised power 1 upon 16 divided by 500 raised power 3 upon 4, okay. Now our k will be equal to, now I if I want to find the k, I have to transpose this exponent on RHS, it will become exponent here but reciprocated, okay. If I have, let me write it here, if I have x to the power m upon n is equal to y, let us say, if I transpose this exponent, so this will become x is equal to y, it will get reciprocated, it will be n upon m, okay, it will get reciprocated. Same stuff I will apply here. So this is q to the power 3 upon 4, and then I have 3w upon r raised power 1 upon 16 divided by 500 raised power 3 upon 4, okay. So this exponent will get reciprocated, it will become 4 upon 3, okay. So this will become, we have q 3 upon 4 multiplying this, so expanding this, so this will get multiplied to this term, so this is 4 upon 3, okay. I fear this will not this will take space here that I don't have, so let me write it here, okay. So I have to see whether I can make it. So which means our k will be equal to, so q to the power 3 upon 4 into this 4 upon 3, then we have 3w upon r, we have 1 upon 60 into this 4 upon 3, okay, divided by 500 3 upon 4 into this 4 upon 3, okay. So 4 4 cancel, 3 3 cancel, 4 4 cancel, 3 3 cancel, 4 1s are 4 4s are 16, okay. So let me see here if I have done some kind of mistake in solving this. I should get 1 upon 4, but I am getting, how it happened here. So let me write it first here. So I got here q 3w upon r raised power, so I got here 1 upon 3, let me write it here. So this will be the demand function for capital, okay. So let me see what has happened to this 1 upon 16, whether it was 1 upon 16 or not. So I guess I have done some mistake at times. So this is 4 4s are 16, 3 1s are 3, so 3 is 3 upon 16, actually it is 3 upon 16, this is 3 upon 16, 3 upon 16. So this will be here 3 upon 16. So here it is 3 upon 16. So I was you know wondering what has happened here. So this is here 3 upon 16. So this 3 and 3 will get cancelled. So obviously it will be 3 upon 16. You can change it if you want. So we are left with only 4 ones are 4 fours are 16. This is 1 upon 4. Okay, so this is our demand function for capital. So what we got the demand function of demand function for capital. So let me write it here. So demand function for capital, we got k is equal to q raised power 3 w upon r raised power 1 upon 4 divided by 500. This is demand function for capital. Okay, so I hope I make myself clear in this video. Because of this lack of the specs, I was not able to show it properly, but I tried my best to give whole picture. How did I get this k is equal to this stuff? Okay, so the brother was getting confused. How did I arrive at this very result? Okay, thank you.